Okay, so this problem, there's really no two ways about it. It is just a lot of brute force. I was looking through the solution for this. I don't think there is an easy way of doing this without working with a lot of ugly numbers. Or I don't. Every solution I can think of for this problem requires a lot of. You have to be very careful with your numbers. There are some tricks you can use. I'll try to go over those here, but be prepared to spend a lot of time on this problem. And sadly, or not sadly, this problem will prepare you well for the rest of the semester, I think. If you can get full credit on this problem, I think you'll be able to get through the semester without much trouble. With that, let's get started. The easiest way to do this problem, I think, and this is not, when I saw the solution, I was quite surprised because I didn't think to do it this way, but it is actually quite easy if you do it this way. Just split this problem into two problems. So ignore this part for now. Solve for A to B. Solve your moment and shear diagrams. Solve your V of x. Get your M of x. Get your theta of x equals, what was it? M of x negative M of x over EI. And your delta x equals integral your theta x. Solve for this for the left-hand side. You'll get some constants that you can't set equal to 0. You'll have more equations than you have unknowns, but that's okay. This is for AB. Do the same thing for BC. So go all the way down here till you have theta of x for BC and delta of x for BC. And once you've gone this far, you can get rid of some of your unknowns through compatibility. So you know that the rotation on AB, the beam has to be smooth. So your slope on the left, I'll use theta B minus has to equal theta B plus. And you know that your delta B minus equals delta B plus. And all this means is that your rotations and deflections have to be the same on either side. So when you come in here, plug in theta at L and theta at 0 and set them equal to each other. And so this theta at L and this theta at 0, remember for this theta we're starting here. Set these equal to each other, and yeah, with that you should eliminate some of the unknowns. And I'm hesitant to go into superposition method right now. You guys apparently learned superposition method. I'm not sure how well that was covered, but yeah. To calculate your maximum deflection, you need to check. You have a free end here, so you need to check this point. You need to check to see find the deflection at this point. Find the location where theta of x equals 0. Right? Do you remember, like, in order to find the minimums and maximums, you found where the slope was equal to 0? This is the slope. Theta x is the derivative of your deflection. So find where theta of x is equal to 0, and wherever theta x is 0, you're going to have either a local minimum or a local maximum. You have two candidates for minimums or maximums. You're interested in the maximum magnitude, so you have two candidates you can choose from. It'll be somewhere here or somewhere here at point C, or somewhere between A and B. Choose whichever one is larger. Choose whichever location is larger. Note that location. Note the magnitude at that location, and that is the solution for this problem. For part B, you're basically doing the same exact thing, except you have an extra load. So basically, for this one, keep all the work you did for part A and just solve this problem. Get theta of x for this problem and delta of x for this problem, and then just add the two of them together. I'll call this little b, delta little b. So add the solution You guys get one big solution from here. This is one big solution. This is one small solution. Add these two solutions together, and that will give you the equations for part B. Do the same thing that you did here. Find where theta of x is equal to 0. Plug find x. Find x, and plug x into delta x. And that is pretty much it. I know I kind of rushed that problem a little bit. This is one of the most important problems in this homework set, I think. Problems 3 and 4 are the most important problems in the homework set, and you can be guaranteed that we will grade either problem 3 or problem 4. We will also grade problems 1 or problem 2. That basically forces you to do all 4 problems, sadly, I know. But yeah, we'll definitely be grading either 3 or 4, so make sure that you do those 2 problems very well. And yeah, as always, let us know if you guys have any questions.